All right, so today I'm going to go over the very last part of our stoichiometry unit with you guys. It's called limiting reactant problems. So let's go through some definitions first. And remember that you guys could pause this anytime you need to, so you could actually copy it down into your notes. So some terms that you want to look at first here are, you have what a limiting reactant is. And you guys know that reactants are over on the left side of the equation, and basically it's a reactant that is going to run out first in the chemical reaction. So you know that in a typical chemical reaction, you don't have unlimited amounts of chemicals that you could use. You might get 5 grams of this or 10 grams of that. So the limiting reactant is just the reactant that runs out first, pretty much. Or another way to put it here is it's the reactant that makes the smallest amount of whatever product it is you're looking at. The excess reactant is just the opposite of this. It's the reactant that you have too much of. So after everything in the reaction happens, this is the reactant. So again, something on the left side of the chemical reaction where you're going to get some left over. So we're going to call that our excess reactant. So these two terms you guys want to be very familiar with. This one over here is called theoretical yield, and this is just how much product is actually made by the limiting reactant. You could think of this as when you actually carry out the calculations for a limiting reactant problem, the theoretical yield is really just your answer. This is how much product of whatever it is that you're actually supposed to get according to calculations in a perfect world. Okay, and a lot of times when you do a lab in here, starting from this point on, we're going to have you calculate something called the percent yield. And the percent yield is made up of two numbers. You have your actual yield. This is whatever amount you actually get from doing a lab. And you took your product over to a scale and you weighed it, and it was like 3 grams of whatever it was. The theoretical yield goes on the bottom, and this is the amount of the product that you were supposed to get, again, in a perfect world according to your stoichiometry calculation. So in the earlier example, I told you guys that maybe you did the lab and you got 2 grams of something, but when you actually calculate it, according to your stoichiometry setup, you maybe were supposed to get like 2.3 grams. So typically, you are going to get an actual yield that is smaller than your theoretical yield. Occasionally, though, you might do a lab where you actually end up making a lot more than your theoretical yield because you have impurities or something else that gets mixed in with your product. And this just gets turned into a percent by timesing it by 100. Okay, so let's go over and look at our very first problem here. It says how many grams of nitrogen gas should be produced, and they're also giving you that water is a product here. And we have 100 grams of N2H4 and 200 grams of N2O4 are getting ignited. And then a few other questions are coming out of here, which we're going to answer all together. It says, what's the percent yield of N2 gas if 125 grams are actually made? And then this last question over here where it says, how much excess reactant remains? This final question that you guys see where it says how much of the excess reactant remains is actually the hardest one to answer. And there's different ways you could set that up, but let's go ahead and talk about the basics of the problem here and how this all ties together with what you already know how to do, which is our stoichiometry setup with the roadmap. So you know that anytime you do stoichiometry, you first need to have a balanced chemical equation. So let's take a look at what this equation is. It has already been balanced for you. So we could see here that we have 2 different reactants. We have N2H4 and then we have N2O4, and then 2 different products. You have water and the nitrogen gas here that is getting made. And this problem is a little bit special compared to the ones that you have done before, because look what's given to us here. You have 100 grams of N2H4. And you also have 200 grams of N2O4. Now, up to now, you know that any time in the problem where they gave you a certain amount of something, we always call that our A. But because you guys have 100 grams of N2H4 and then again 200 grams of N2O4, you really have two different A's that we're dealing with. And they're both on the reactant side. Now, we need a B in order to carry out a stoichiometry problem. And we could get this B by looking at the question. It says, how many grams of nitrogen gas should be produced? So we're looking over here at the product side, and nitrogen gas is going to be our B. Okay, we only have one B here. So basically the issue is this. You have the setup here where we have 100 grams of the N2H4 being used, and we're mixing it together with 200 grams, and I'm not including all the decimal places, but we have 200 grams of the N2O4 being used, and they want to know, hey, how much of this nitrogen gas is really going to get made? You have the scenario here where you have 100 grams here, 200 grams there. One of these guys is going to limit how much N2 we can make. And one of these guys here is we're going to have too much of. So we're going to have a limiting reactant and then an excess reactant. And we're trying to figure out really how much N2 is really going to get made based off of this problem. So let's take a look at the setup here. We're going to do our first stoichiometry setup. And let me go ahead and put this out there. And again, remember, you guys could pause this so you could actually copy it down into your notes. But let me walk you through what you see over here. So I'm starting off with 100 grams of N2H4. So I'm going to go ahead and carry out this one. Oh, darn it. Let's go back. So I'm going to go ahead and carry out my very first stoichiometry setup with 100 grams of N2H4. And my B that I'm going to go to is for nitrogen. So I am pretty much following my roadmap. I have 100 grams of N2H4. I'm using the molar mass right here. And then I'm going into the stoichiometric switch step. So it's a 3:2 ratio. And then I'm going out into grams of nitrogen. So based off of this calculation, if I had 100 grams of N2H4, I can make 131.1 grams of N2. Okay. But remember here, the issue is that we actually have a whole nother A to go ahead and do another setup for. So I'm going to set up a whole nother stoichiometry setup, except for this time, my A is going to be the N2O4, and we're going to start with 200 grams of that. And then again, we're going to go all the way out to the B of N2. So let's look at our setup for the stoichiometry there. Okay, so you could again pause this and go ahead and jot this down, but we're starting off with 200 grams of N2O4, okay? And again, we're going through all the stoichiometry steps here, and we're going to grams of N2 here for this final part. Now, let's go ahead and analyze this information that we have, as we just did two stoichiometry setups. So according to this, if you were to look right here, according to the second stoich setup that we did, we're being told that we can make 182.7 grams of nitrogen, okay, if we use 200 grams of N2O4. So which one is our correct answer? Is it 131 grams of nitrogen that we could make, or is it really 182 grams of nitrogen that we could make? And here's what you guys need to remember. It's always going to be your smaller number. Your 131.1 grams of nitrogen right here, we are going to call this guy our theoretical yield. Okay, here's what this means. My 100 grams of N2H4 here, okay, it is going to limit how much nitrogen gas I could really make. We're only able to make 131 grams of nitrogen. And then if we had 200 grams of N2O4, it says that we can make 182.7 grams of nitrogen right here. But it's always a smaller number of the two. So we're really going to make 131. And this N2H4, let's go ahead and label what this is. This guy right here is your limiting reactant. Okay, so why is the N2H4 called our limiting reactant? It's because we, with the 100 grams of the N2H4 that we had, it's only able to make 131 grams of nitrogen. This guy runs out first. So that's our limiting reactant. This means that the N2O4 that we have down right here. Okay, so if we're able to use 200 grams of the N2O4, we were told that based on the stoichiometry, we could actually make 183 grams of the nitrogen here. So the N2H or the N2O4 is our excess reactant. It's the one that we have too much of, okay? And unfortunately, we can't make 183 grams of nitrogen because the N2H4 is going to run out first. Okay, so again, you have two different amounts of reactants that we're kind of igniting together here according to this chemical reaction, but the 100 grams of the N2H4 is really going to determine how much of the N2 we can make. Now, some of you guys might be thinking, well, Mrs. Han, it seems like a waste of time to actually do two stoichiometry setups. Can't we just look at the numbers? 100 grams is obviously less than 200 grams of the N2O4, so I don't need to do all this work to figure out the limiting reactant. Well, remember this, you actually do want to carry out the two stoichiometry setups. The 100 grams versus the 200 grams, it happened to be that this ended up being the limiting reactant, but a bigger indicator here of what is going to actually limit your chemical reaction is this guy right here, your multimole ratio. So if you end up getting a really high ratio, then even if you have a very little amount of the reactant, that might end up really being your excess. And the opposite would be true if you had like a large amount of this particular reactant, but your mole ratio was really small, you might end up with a very little amount of your product. So it is actually really important for you guys to go through and carry out the stoichiometry setup twice to actually get to your answer. And let's go ahead and take a look at what's next right here. Okay, so this is just going through and summarizing what we talked about. So from having done the two stoich setups, the 131 grams of N2 is our actual, it's our theoretical yield. So in a perfect world scenario, this is the max amount of N2 that could actually get made based on our conditions. And how do you again know the theoretical yield after you've done your two stoich setups? You're going to look for the smaller amount, and that's going to be your product, your theoretical yield product. You'll also be asked to identify what was limiting the reactant or limiting the reaction. So whichever reactant that you guys use that gave you that small number, that's going to be your limiting. And then the other reactant that was used, the N2O4, that's going to be what you're going to have too much of. So the N2O4 became our excess reactant right here. And I'm going to go ahead and stop it here. And then I think I need to make another screencast video because I'm going to run out of time. Yeah, so go ahead and make sure you click on the second one to get the rest of the notes.